What is the largest earthquake which can theoretically happen? While the internet might claim that a magnitude 10 or 11 earthquake is currently possible via a series of tectonic faults all rupturing at once, they are flat out wrong. Instead, the answer to this question is still absurdly large, with that being a magnitude 9.6. If you want to be even more specific, a magnitude 9.629. But how can I say this? To start, the magnitude a specific active fault line can produce is directly linked to its length that can rupture in a single event. The longer a fault is, the longer of a distance that can rupture in a single event, translating to an ability to produce a larger earthquake than from a fault line hypothetically half its length. If we look at the planet's largest magnitude earthquakes, which I will define as magnitude 9.0 or greater, you will note that they only occur in a singular geologic setting, the subduction zone of a convergent tectonic plate boundary. As one tectonic plate subducts underneath another, friction from the subducting plate starts pulling the overlying plate downwards and into the mantle. This stress builds up until it overcomes the friction being applied to it, causing a length of the fault hundreds of kilometers long to snap back upwards, often generating a tsunami. However, the overall length of a particular subduction zone does not directly translate to the overall length that can rupture in a singular major earthquake. As, due to a number of factors including how specific segments of a subduction zone formed at different times and their average motion and direction, subduction zones are subdivided into multiple segments. Each of these segments move and behave in slightly different manners, making it difficult for a major earthquake to rupture portions of more than two major segments at a time, marking a sort of theoretical limit. However, looking for the two longest combined adjacent major fault segments alone will not allow us to identify where in the world the largest hypothetical earthquake could strike. To explain why, let us look at a simplified version of the moment magnitude earthquake scale, which is used to calculate the magnitude of various earthquakes based on a specific set of observed parameters. Factors which determine the magnitude of an earthquake include not only the rupture length of an earthquake, but also the rupture width, since larger earthquakes involve a rectangular region that slips, the average displacement the rectangle which slips moves, and finally the rigidity of the fault rock in question. That latter point, which I have labeled as variable d, is important. The more rigid a rock is, the higher of a magnitude a specific area is capable of producing. Since basalt has about double the rigidity of most land rock types, we can in essence discard all of the convergent plate boundaries on land, only looking at subduction zones in oceans and sea settings, since basalt comprises the majority of oceanic crust. Longer megathrust ruptures have occurred than what I am about to specify, but involving lesser average slip values. With this taken into account, the largest tectonic earthquake possible that could ever occur in the world as it is right now would involve a 1,024 km long and 200 km wide segment of land centered beneath and between the southern tip of Chile's Chiloé Island to the south all the way to 4 km north of the city of Pichilemu to the north. In our highly unlikely largest magnitude earthquake scenario, this massive area could move an average of up to 28.44 meters or 93.32 feet. This might seem like an improbable figure, but I want to remind everyone that such a massive earthquake has in essence sort of already happened. As, on May 22, 1960, the largest earthquake recorded in human history struck a 900 km long and 150 km wide subsection of this segment, which moved an average of 25 meters, having a magnitude of a 9.5. However, a non-tectonic earthquake larger than a magnitude 9.629 is possible under a specific condition. If an asteroid measuring more than 8 km wide or comet measuring more than 5.5 km wide impacted Earth, since such impacts release massive amounts of seismic waves. Events of this large size are absurdly rare, with one such impact striking Earth an average of once every 53 million years and being sufficient to cause a mass extinction of sorts. However, two notable ancient asteroid impacts create even larger earthquakes. The 17.5-kilometer-wide Yucatan Peninsula impactor that wiped out the non-avian dinosaurs generated a magnitude 10.3 earthquake 66.043 million years ago, while the impact of the 6,100-kilometer-wide Theia protoplanet into Earth 4.53 billion years ago generated the equivalent of a magnitude 15 earthquake. As a final note, I would like to thank my new YouTube channel member, Falcon and Trident, for supporting my work.